Hi, I'm Paul. Welcome to the code-dispenser channel. Today we're going to build an accessible tab control for Blazor following the ARIA authoring practice guidelines for the tab pattern, and we will do this without adding any JavaScript. The component has various parameters that allows us to control its styling, ARIA information for keyboard users and screen readers, such as which tab activation mode to use, manual or automatic, as is described within the ARIA tab pattern guidelines. We will also add support for two-way binding in order to bind the index of the active tab. We will then be able to use either the bind syntax or an event handler to get the active tab index. Let's have a quick look at the finished tab control in action. I will refresh the current page so everything is reset. The active tab index parameter was set to 1, so the weather tab should be active by default given 0 based collections. We can cycle through the tabs programmatically, or we can navigate using the keyboard, which is the primary concern of the control. We access the tab control first by tabbing to it, and once in the list of tabs we can then use the left and right arrow keys to cycle through the tabs. The home key to set focus to the first tab and the end key to set focus to the last tab. Currently we are in manual tab activation mode, so keyboard users, after setting focus on a tab, will then need to press the enter or space key to activate the tab. Once activated, the user can then use the tab key to go to the first focusable element within the tab panel, or have the focus set on the tab panel itself if there is no focusable panel content. I opted to make the tab page content container element focusable or not via a component parameter value that you manually set on each tab page element. You can certainly use JavaScript to inspect the content and have this parameter set via code if you so wish. The inspection code is similar to that I included in my focus trap video if you want to negate manual inspection. The wrap tabs parameter is set to false, so the text in the tabs will just line break. Let's close the app, look at the markup and change some of the available parameter values. The markup for the control is simple. It only contains tab page components that have two render fragment parameters: tab content for any custom tab markup and tab page content for the page content. At the tab control level, we can set the starting tab index value using the active tab index parameter, have manual or automatic tab activation mode via the auto activate panel parameter, set whether or not to wrap the tabs using the wrap tabs parameter, change the background color value for the tab and page content area using the tab and panel BG color parameter, or change the focus color using the tab focus color parameter. On each tab page element we can set the ARIA tab name, which is a required parameter to hold the text that screen readers should announce. If no custom markup is added, the ARIA tab name value is used for the text displayed in the tab title area. Any custom content for the tab title area is hidden from screen readers. The add panel tab index parameter adds a tab index to the tab page content area when set to true. This is for when there is no focusable elements within the content area. The weather tab makes use of both the tab content render fragment to add markup for an icon, as well as having its add panel tab index parameter set to true. The control uses the Blazor event callbacks and parameter naming convention in order to make use of two-way binding. So you can either use the @bind active tab index equals variable name syntax to keep track of the tab index, or use an event handler ensuring to update the variable used for the active tab index parameter. For the demo, as you can see in the markup, I used the active tab index changed event and handler instead of the @bind syntax. Let's change a couple of the parameters and finish off the demo before starting work on the control. Now when a keyboard user navigates the tabs using the arrow, home or N keys, the tab is automatically activated with its associated page content displayed. When we shrink the page, as we have set the wrap tabs parameter to true, the tab should now wrap instead of line breaks appearing within the tab title area. Okay, let's get started. We're going to build the tab control from scratch, but the completed code is available in my GitHub repository, the link of which is in the video description below. I am using a Blazor interactive server web app for this project called Blazor Builds, and have added a separate Razor library project called blazorbuilds.components specifically for the tab control, but a separate project is not required. Equally, you could use any of the interactive template options. I have already added folders to the www root for our web assets, in this case just a CSS file, as well as folders for our Sassy CSS files, as we'll be using a CSS preprocessor to create our CSS file. I use Sassy CSS for all of my web projects, and as such already have Visual Studio configured via a free marketplace extension. I created a short 4-minute video regarding this and how to get up and running if this is new to you. The link to that video is also in the video description below. I have set the Sass configuration to have the CSS file output to the CSS folder that I created within the web root folder. I also updated the app.razor file in the server project to include a link to our CSS style sheet, as well as to add a project reference from the server project to our component project. There are a few ways to build Blazor components comprised of a parent and child components. One way involves separation of the render fragments into separate files, making more use of cascading values. The other generally involves less separation and more loop structures. Our tab control is going to be built using the latter approach. Our tab control will be comprised of two component files, the parent tab control and a tab page component for its children. The tab control will contain a little more code than I would normally put in a Razor file, so we will use a code behind for this. First we'll create a folder for our tab control. Next we will add the tab control Razor component and then the tab page Razor component. We can delete the contents of the tab control file and add a class file to the folder named tabcontrol.razor.cs. We need to change it to be a public partial class for it to act as a code behind file. We will add using statements to both of the imports.razor files so our control can be referenced correctly from any Razor file in either project. Before we get to work on the Blazor and C# side of things, we will do most of the HTML and CSS work up front. This is so we have something to look at before we start adding any code. We will use hot reload whilst doing the CSS. If you run into any issues with hot reload, you may need to add the statement app.useResponseCompression within the environment is development block of the program file, as there used to be some issues caused by SignalR that prevented the CSS from refreshing. We will use a containing div for our tab control with a class of tab-control for any styling at that level. We will use the BEM block element modifier naming convention for our CSS. This tab-control class is the block part of BEM. We know that we will need a variable number of tabs, so let's add another div with a class of tab-control __ tabs. This is an element within the BEM convention. Flexbox will be perfect for handling the tabs, so we can wrap them if required. For each tab following the ARIA authoring pattern, we will use buttons for these. We will also have to provide a way for screen readers to associate each tab to its panel, i.e. the page content, and vice versa. To achieve this, we will need to use the ID ARIA controls attributes. Each tab needs to be reachable by way of the tab key when selected, i.e. active. Otherwise, the arrow keys are used to navigate and set focus on the tab, or to both set focus and activate depending on mode, manual or automatic. To achieve this, we will need to programmatically toggle the tab index from 0 to -1. When the tab is active with its content displayed, we will also need to toggle an ARIA selected attribute for users of screen readers, as well as providing some styling for this state for other users. We will add another class for this that will modify an existing class value. This is a modifier in BEM. For each tab, i.e. the button content, we will add a span to hold either custom content or the title of the tab. We can use the ARIA hidden attribute on the span to ensure it and its contents are hidden from screen readers, providing an ARIA label attribute on the button for the screen reader. As this ARIA label value will be populated by a parameter on our tab page component, our code can also make use of this value for content if no content is provided for the span. Now we have the tabs, we need divs to hold each tab's associated tab page content. Just for now, while we're doing some styling, we will include the divs here, but later the tab page component will hold this markup. In order to link tabs to tab page content for screen readers, we will need to link the value in the ARIA controls attribute on the tabs to the ID attribute used on the page content, and equally link the ARIA labeled by attribute on the page content div back to the tab via the tab's ID attribute. This is so screen readers can announce it's entering the content for the tab. In our case, this announced value will be the value of the ARIA label that we added. We will test all of this at the end of the video with the NVDA screen reader. It should be noted that we have added all of the ARIA attributes and roles as indicated within the ARIA authoring guidelines for the tab pattern. That about does it for the markup. Let's add the tab control component to the home page and work on the CSS. As we are using Sassy CSS, we're going to add a couple of partial files. The naming convention for partial files is that they start with an underscore. This lets the compiler know that these files are used by other files and not to be output as separate CSS files. In the root partial file, we will add 3 CSS variables to control the color of the lines, the background color of the tabs and the tab page content, and the color used for focus rectangles. We need to add a use statement to our main SCSS file to have the partial files included. Right, let's run the app and see what our control looks like. Okay, not that good at the moment. We will style our markup using hot reload to see the changes. First, let's add our block element, the tab control class, and then the tab control content element class. We will need to hide inactive tab content, so let's add a hidden modifier class. The double dash is the naming convention in BEM to indicate a modifier. If you are unfamiliar with Sassy CSS syntax, the ampersands just denote the parent selector name, so where we add ampersand __ content, the preprocessor will output a class name of tab-control __ content, and then for our modifier, as we have a nested ampersand, it will output tab-control __ content -- hidden. Now let's add the tab container element class. As we are using Flexbox, we'll add a modifier class so we have the choice of wrapping the tabs instead of just using line breaks. Let's style the tab. The reason for the position relative and moving down 1 pixel specified by the top property is a trick that we will play to make the border line between the tab and the page content disappear. By using position relative and moving down 1 pixel, the 1 pixel borders are now on top of each other. All we need to do now is to ensure that the active tab is on top and remove its bottom border. As both it and the page content use the same solid background color, the tab background color will cover the top border of the content, making it look as though they are just one element, not the two. If you prefer the border lines to show, you can just set the background color to use a value with an alpha channel. We just need to add a bit of style for our tab title class for the tab name and a little bit to control the alignment of any custom markup, and then we're done. I will add some embellishments such as hover and focus states off camera. Whilst off camera, I also added a couple more folders and classes. The global strings class just holds all of the string constants that we need, such as all the class and variable names that we have used. The extension class is just a preference of mine. I like readable one-line statements and expression body methods. But as ifs are statements, you can't use them in the expression body. The extension method makes this possible. I think it makes things a little more readable. But use if statements instead if you feel like what I have done is an abomination. I have also added the using statements for these to the imports.razor file, so we don't need to add any references in any Razor code. We will need to make it possible for the parent tab control and its children tab pages to communicate with each other. For this, we will let the parent tab control hold a collection of the tab pages and have each tab page obtain a reference to its parent by using a cascading value parameter. The children can then use this reference to call a method on the parent to have themselves added to its tab page collection. We will first add the private fields, component parameters and properties. The enum is needed for a general method that we will write to allow code in the Razor file to request the classes or style variable values it needs, which may also be dependent on the active state or parameter values. The dictionary of element references will allow us to hold references to each tab button so we can set focus to them when using the arrow keys for navigation. The active tab index and focus index will help us keep track of which tab is active and which has the focus. These could be the same or different depending on the activation mode. Remember that in manual mode, a keyboard user could be on an active tab and then use the arrow keys to find other tabs, setting the focus and then using the enter or space key to activate the tab. The CSS class private fields are not actually needed. I originally used them in the method that uses the enumeration. These have been removed from the source code. The parameter child content render fragment is where all of the tab pages will go. The parameters active tab index changed, event callback and active tab index forms a two-way binding mechanism for getting and setting which tab is active using its collection index value. The auto activation panel parameter is the one that will determine which activation mode should be used, manual or automatic. The others are self-explanatory. The internal property active tab just holds the current active tab page that a tab page can access so it can check if it's the actual active page. The tab control determines which tab is active, and the tab page ensures its page content is visible or hidden based on the active tab. Let's now add the cascading value parameter to the tab control markup so any children can get a reference to the tab control. We can delete the content divs as they were just temporary and get rid of one of the buttons. The other we will leave as a reminder of what's required for when we add a for each loop to build all of the tabs. The recipient of the cascading value is the child content render fragment. This child content will be our tab page components, one for each page. We need to add a method in the tab control for each tab page to call to have themselves added to the tab control's tab page collection. After that, we can then go and work on the tab page component. We can get rid of the existing markup and add a using statement for a dispose method that we will use to have the tab pages removed from the parent when the component is disposed. As we haven't added a remove method yet, let's go fix that before we continue. The first thing we need to add is a cascading parameter of type tab control to hold the reference cascaded down from the parent. Next we will add a couple of render fragments, one for the tab name markup and another for the actual tab page content. The add panel tab index is the configurable parameter that will determine whether or not to add a tab stop on the content div to set focus there when the content does not have any focusable elements. As mentioned earlier, you can add JavaScript for this if you so wish. The ARIA tab name is what will be used by screen readers and provides a default value if no custom tab name markup is provided or required. Both of these parameters are marked with the editor required attribute to remind the developers to add these. In the case of the ARIA tab name, we will also raise an exception if a value is not supplied. The CSS fields will hold the class list for our div. The focus style variable will hold the CSS variable name and value to use. We will set the CSS variable used for the focus rectangle color to the color value that may have been supplied for the tab control's tab focus color parameter. The internal tab panel ID and tab ID are used to supply the values for the attributes needed to link the tabs to their content pages so screen readers can make the appropriate announcements. Let's add the rest of the code and then the markup. There really isn't much logic in this code. The tab page adds itself to the parent tab control using the reference it got from the cascading parameter. During the onParameter set event, we check and assign the appropriate CSS classes or style values. And then we use the dispose method to remove the tab page from the tab control. The markup is similarly simple. We just use our variables and properties to update the div attributes and then place whatever content is contained in the render fragment inside of it. Let's update the home page with some markup so we can check to see what things look like now. I will copy and paste the code that was used for the demo to the home page to save typing the tab page content, as we have all the parameter and render fragments in place. As a side note, given this was just demo code, in order to display the icon for the weather tab, I just added a reference to the CDN for Bootstrap. Generally, I do not use CDNs and prefer having all assets stored locally. Okay, not much to look at, just the one button with the hard-coded attribute values that we left. We need to add a general method that we can use to get the correct class or style information for our tab control and finish off the markup now we have the tab page component completed. We also need to add a using statement to our code behind file to be able to reference our global string class that holds our string constants, as the one we added to the imports.razor file is no good for code behinds. The method is not complex. We just return a string value containing the information being requested determined by the style info enum. We check and set default values for any empty parameters, add modifier classes based on whether the tab is active, and add modifier classes if the wrap tabs parameter is set to true. Let's finish off the tab control markup. Let's use our getStyleInfo method. As our tab control now holds a collection of tab pages, we can just use a simple for each loop to get at each tab page in the collection and use this information to create a button for each tab page using the appropriate values for the button attributes. In this for each loop, we get the index of the tab page and compare it against the current active tab index to check whether we are dealing with the active tab. The captured index value is used as the key for our dictionary of button element references, as we will need to programmatically set focus to the tabs using the keyboard. It may appear a little odd to just add a new element reference to the dictionary when we need the reference to the button element. We do this as we need an element reference slot in the dictionary that we can use for the button. We can now assign the button to the element reference in our dictionary using the @ref directive. The loop basically allows us to create the tabs and populate all of the attributes, linking IDs to ARIA controls and labels with full access to either the tab control or tab page component. The only other thing to note is the use of the tab page's tab content render fragment parameter. As it's a property on the tab page, we can just have its content output at this location. Let's run the app and see what we have. I think we need to open the DevTools to see what's happened. It looks like we have the tab control and the tab page content, but we have no tabs. Let's close the browser and look at the code to understand why. Let's add the onAfterRender event, which is the last part of the component lifecycle. Add a breakpoint, run the code, and check our tab page collection. So it looks like each page has added itself, so why no tabs? The tabs have been added to the collection. The problem is we have not informed Blazor that our internal state has changed and that it should re-render to have the display updated. Let's check this by amending the onAfterRender event to call state has changed on the first render. Now we see all of the tabs. If we look in the DevTools, we see all of the buttons and divs for the content. We are now just missing having an active tab, which would then add the highlight to the tab, as well as cause the page content for that div to be displayed. In order to make all of this work, we need to check for the active tab index parameter value in the onParameterSetAsync event. Have a method to both check and raise a tab changed event for two-way binding and update the onAfterRender async. As we know, this needs to cause a re-render on its first render. The first method we need to add is a raisTabChange method that we can use both to set which tab is active and inform users of the current active tab index. We check both the current active tab index and requested tab index, as there is no point raising an event for the tab that we are currently on. We will also be calling this method in the button's onClick event, and the end user could just keep clicking on the tab. That's why we do this check. If the values are different, we then check for an event binding, and if there is one, we then raise the event. The switch expression is to check for values that may have come in via code parameters, such as from the demo cycle index button, rather than raise an exception if the tab index is out of bounds of our tab page collection. I opted just to cycle the index, assigning it to 0 or the last index of our tab page collection. As mentioned, the tab index parameter may have been assigned programmatically. This can only be done via the active tab index parameter, so we will also need to call the raised_tab_change method from the onParametersSetAsync method as well. You may be wondering why I removed the call to status_changed when just minutes ago we determined that Blazor needed this on the very first render. The reason for this is that the raised_tab_change method invokes the active tab index changed, which updates the client components parameter, which then causes the onParameterSet event to fire, causing a re-render. This is perfectly normal. However, before uploading the code to GitHub, I added one more line of code in the onAfterRender event to call status_changed, but only in the following circumstance. It's the first render and the hasDelegate property of the active tab index changed event callback is false, meaning the event binding is not being used. Although we don't have this in code, we are unaffected because we are using the event bindings in the markup on the home page. Let's check our progress. We haven't added the keyboard or button event handlers yet, so clicking the tabs and pressing enter did nothing. However, the button that cycles through the tabs worked fine, as that just updates the active tab index, which then calls the raised_tab_change method. Let's add the method to handle the key press event. We need to be able to use the arrow keys to navigate the tabs. The tab key should take us to an active tab if it's the next in the sequence, or the first focusable element within the tab page content if that's next in the sequence. We also need to keep track of which tab has the focus for the arrow keys. As well as the arrow keys, the home key should take the end user to the first tab and the end key to the last tab. Let's wire up our handler to the div that holds all of the tabs, and whilst we are altering the markup, let's wire up the button on click event. All of that appears to be working fine as I tab through the page and use the arrow keys. Currently we have the manual tab activation mode working, so we just need a way to make things work for the automatic activation. What we need for that is to be able to activate the tab and display the tab page content as soon as the tab receives a focus, without the end user needing to press the enter or space key. We already have working code in place that checks indexes, sets the tab is active and raises the active tab index changed event, so all we need to do is to add an event handler for the buttons on focus event. We can then check if the auto active panel parameter is set to true, and if so, call our raised_tab_change method as normal, passing it the index of the tab that has just received the focus. Let's wire up our check raised_tab_change method to the buttons on focus event. All that's left now is to change the auto active panel parameter value to true in the tab control on the home page and see if it works. That's it, we're done. Let's close everything, run the app and use the free NVDA screen reader to ensure it reads everything correctly.
Loading complete. Cycle/activate tab button. Tab control, whether data tab selected 2 of 4. Whether data property page, whether heading level 1 this component demonstrate. Tab control, whether data tab selected 2 of 4. ARIA tab pattern information tab 1 of 4. Counter tab 4 of 4. Selected. Counter property page click me button. Current count 1. Tab control, counter tab selected 4 of 4. ARIA sum form tab 3 of 4. Selected. ARIA sum form property page, field 1, edit. Tab control, ARIA sum form tab selected 3 of 4. Weather data tab 2 of 4. ARIA tab pattern information tab 1 of 4. Selected. ARIA tab pattern information property page tabs pattern opens in new window.
Everything was announced correctly. Please note, as mentioned in my focus trap video, accessibility can be very problematic as each screen reader may interpret things differently. This can be compounded by the combination of screen reader and browser, so you may have to go beyond what we have done here depending on your requirements and target audience. On that note, I leave you a challenge. Currently, if you click the Cycle Tabs button, the focus remains on the button and the screen reader does not announce the change. See if you can come up with a way to change the tab programmatically and have the screen reader announce this change. I have added the solution to the end of the tab control file in the source code for you to check to see the approach I took. I hope you enjoyed this video, and please feel free to leave good or bad comments. If you want to support the channel, my Ko-fi link is in the video description below, along with a link to the GitHub repository for the source code. Thanks for watching. Until next time, bye for now.